Welcome back. Today we're going to solve this question 17 of QCAA External Assessment Paper 2 in 2023. So this is a vectors calculus question involving velocity and acceleration. So basically, we have the object flying upwards. So first upwards, but they eventually will be travel like a parabola. But the velocity, initial velocity is so initial velocity, well, let's write down. Initial velocity is 15 minutes per second times by cosine, because there's an angle, so in that direction. And the J component is a 54 degree. So there's two components for the velocity, initial velocity. So there's a drone somewhere. So let's say here there's a drone. So observer distance from the origin is 220 meters from the original point. Observer watch a drone here, right? So he made assumption. He commented, so the object will hit or pass the drone around 2 to 2.5 seconds, so between 2 and 2.5 seconds. So the object will reach the drone. He also predicted the object will still moving upwards direction after past the drone. So there's a question mark. So there's two assumptions. One is the object passed the drone between 2 and 2.5 seconds. But whether it's continue on or whether it's already, when the path to the drone is already go downwards, we don't know. So it could be, so we need to verify those two claims, reasonable or not. So let's do that. Let's find out so there's a possibility there will be both incorrect or one correct or the other one's not correct. So first of all, I'm going to use the vectors calculus to find a couple of things. So we need first we need a position vector, which is called RT. So we don't know yet. So therefore, we need to have the VT first. So velocity vector, we don't know either. So therefore, we need to first find a acceleration vector first, because the acceleration vector so this object is thrown upwards. So therefore, the acceleration vector is negative 9.8 in the direction upwards. So that's upwards, J. So therefore, velocity vector is integration of acceleration vector. So we will find that velocity vector is in negative 9.8 t j plus c. So let's decide what the c is. So we know the initial velocity is given of that. So we've done, that's the initial velocity 15 times by the angle cosine angle, and that's the horizontal component and the vertical component. So therefore my C is equal to this. So therefore we substitute the velocity vector. So the horizontal component is 15 times by cosine 54 degree, and the vertical component, it's got this minus 9.8 t. So now we're going to do the displacement or position vector for r. So let's integrate a vt. So therefore we integrate two components individually. So the x component is, so that's called vx. So this is rx p, and that's the ry. So there's a two different component. So y component is this. So we got two components. Let's find a C first, because C is a still question mark. So because of the position at the initial position was 0, so the C must be 0. So therefore my position vector is using this. So there's a two components there, x component and a y component of the position vector. So now we understand that the horizontally, when the observer standing horizontally at 20 meters. So therefore we can solve for the time by using the x component, 15 times by cosine 54 degree t equal to 20. So we find a t equal to roughly about using graphics calculator, 2.27 seconds. So the time the object passes drone is about 2.27. So that's horizontally. So therefore, the first observation was correct. So which is so the statement 1 was right, because it's a 2.27 between 2 and 2.5 seconds. However, let's see if the objects do pass after 2.2 seconds, still continue to move on upwards or not. So we can solve for the maximum value for the y component. See if it's how high can be reached for the object. So this is the y component, but we can't solve with our calculator. So this is a quadratic. So if we solve a quadratic maximum, we can use graphics calculator. So time is about 1.27. So therefore, the drones already reached to the maximum height before even pass the drone. So therefore, the second assumption is not reasonable, because the drone is reached to the maximum height before passes the drone. Okay, so that's we're using vector calculus to verify the reasonableness of the observer's comment. So this question is, I would say it's a complex, but we might say complex unfamiliar, all right? Because of the couple of things that we need to know is, how do you find that those two different components, x component, y component, then use the graphics calculator to find that time for each claim. So that's the solution. So hopefully you understand the solution, and if you do, please give us thumbs up, and also don't forget to subscribe channel. Thanks for watching. I'll see you next time.